Welcome to my presentation of Aviation Companion. This is Aviation Companion, a Bluetooth device that connects to aviation radios and receives frequency settings from the navigation app Skydemon. With Aviation Companion, you can send radio frequencies from Skydemon to aviation radios via RS-232 over a cable to the radio. You can also send GPS positions to autopilots and receive GPS and traffic information in the opposite direction to Skydemon. It has a fixed cable to increase its reliability. It is also potted with a high-quality polyurethane compound that protects it from humidity and vibration. As you can see, it's really small, like a little finger. Aviation Companion is delivered with an extension cable. Both the fixed cable and the extension cable has 4 conductors. Black for ground, the chassis in the plane minus on the battery. Red for power, the typical plus 14 volts. White for transmit data to the radio. And green for receive data from the radio. The conductors has to be soldered or crimped to the connector on the radio, just like the connections for headsets are soldered to the connector on the radio. Just like the headset can be connected and disconnected with its plug, Aviation Companion can be connected or disconnected with its plug. Here are a cable panel mounting. If you want it to be really easy to remove Aviation Companion from the plane, for example for moving it between planes, you can use this. You then put the connector on the instrument panel, like for the headsets. It is similar to the extension cable delivered with Aviation Companion, but it can be mounted on the instrument panels or similar, with a maximum thickness of 2.5 millimeters. If you use one of the extension cables, you can easily remove and put back the Aviation Companion in the plane. For a more compact installation, just cut off the 3.5 millimeter plug and solder or crimp the cable directly to the radius connector, without using an extension cable. Some radios, like Becker 6201 and similar, is controlled over RS422 instead of RS232. For them I have this one, a version with RS422 communication. It connects with 6 conductors, ground black, red power and 2 data pairs, green and white for receive data and blue and yellow for transmit data. There are no extension cables supplied with this version, because the connectors on it would be too big to be practical. For Becker AT6201 radios and its different versions, you can use this only if the optional extra tandem display is not connected. Because if you have the tandem display, the needed connector pins are already occupied on the radio. Aviation Companion is connected to the lower connector on the radio. Often the lower connector has nothing else connected, and then I can supply a suitable connector on the cable at a small extra cost, like this. Still, the red cable for power must be connected by you, either to the upper connector or elsewhere where power is available. Aviation Companion can be mounted with Velcro on the instrument panel or behind the instrument panel. It has very low weight, so it works well. It has a green light that blinks when it's powered but not connected to Skydemon. Skydemon connects to it when you start a flight or a simulation. The light then gets steady, like this. At moments of communication, the light blinks shortly, like now. To use Aviation Companion with Skydemon, you need to first configure Skydemon to use it. First start Skydemon and connect power to Aviation Companion. It's now blinking green. Select Configuration. Select Connectivity. Select Add Bluetooth device at the bottom. Select your device from the list. Choose radio to use it with your radio. Select what kind of radio you use, Funke this time. Select if you want the frequency to standby position or to active position. Standby is good. And save the configuration. Aviation Companion blinks green, indicating it is ready for connection to Skydemon. So let's go flying. Now the green light is steady, indicating it's communicating with Skydemon. I touch the screen and get an information window with frequencies. When I touch a frequency, it is transferred to the radio. The green light blinks briefly and a message on the screen confirms the transfer. Let's touch the screen again and select another frequency. If we go to a radio tab, there are frequencies relevant to our location to choose from. Same with the airfields tab. Relevant frequencies for the airfield to choose from. Let's stop the navigation. Now Aviation Companion blinks again, indicating it's ready for new connection. Here I'm sitting in a small plane, an Artec Faeta NG, with a Funke radio, Skydemon, and a Bluetooth companion. An extension cable is soldered to the rear connector on the radio. It is the same cable as delivered with Aviation Companion. It looks like this. Here comes the cable. I have connected Aviation Companion to it and put Aviation Companion on the dashboard with Velcro for the demo. Usually it's on the rear side of the dashboard. We can see it blinks green. That means it's ready for Bluetooth connection. When a Skydemon connects, it will get steady. Let's go flying. I touch the screen and an information window appears. I select a frequency and it transfers to a radio. It is confirmed on the screen. You can get a new frequency to a radio as often you like. Skydemon can send frequencies from different tabs. Here from the Airfields tab. Transferred to the radio and confirmed on the screen. If you travel far away, you can always get relevant frequencies from Skydemon to send to your radio. When Skydemon has Bluetooth connection with Aviation Companion, the light is steady. At every transfer, the green light blinks briefly. When we stop navigating, Skydemon disconnects from Aviation Companion, and the steady green lights get blinking. Here we have an Aeros 2 trike with an KRT2 radio, Skydemon and Aviation Companion. At the bottom of the dashboard there are a connector where Aviation Companion is connected. Plug it in like a headset. When we go flying, Skydemon connects to Aviation Companion and we get a steady green light. We select frequencies that are sent to the radio. Now let's have a look on how to connect the cable to your radio. There are only 4 wires conductors to connect: ground, power, transmit and receive. That's all. Ground, transmit and receive is always connected to the same connector on the radio. Look in your radio manual what connection pins are for these signals. The power, typically plus 14 volts, might be available on the same connector, but you might need to connect it to another connector or to a plane's power distribution system, depending on your plane and your radio. You can choose to connect the extension cable to a radio or to connect the cable from an Aviation Companion directly to a radio. Then you have to cut off the 3.5 mm plug on the cable first. There might already be a connector with other conductors connected to a radio. Then you will add these conductors to that same connector. If not, you have to obtain a suitable connector first. There can be 2 different types of connectors for this on the radio: soldered and crimped. If there already are a connector with cables connected to the radio on this connector, you have to use that. If not, you may select either solder or crimp connector, as you prefer. With soldered connector, you need to put a heat shrink tube over the solderings to protect the conductors. With crimp connector, you have to obtain a suitable crimp tool. In both cases, you will have to arrange a mechanical mounting for the cable in the connector housing, like on the connector to the right. In that connector, we can also see that the red power conductor is brought out of the connector to find power elsewhere. First, we have a look on the crimping, and then we look at the soldering. With crimping, the connector is supplied without contact elements, terminals. We get the terminals separately. We crimp the terminals on each conductor and just push them into the connector in the desired position. Looking from the right, we first remove insulation from the tip of the conductor to get the bare copper. The uninsulated piece must have a correct length to fit the crimp terminal. Next from right is a crimp terminal. On the top is a tab from the packaging roll. We will break it off after crimping. Until then, we keep it to hold it with. If you look carefully, you can see there are 2 crimp sections on the terminal, one for copper part and one for the plastic. This is to hold the conductor properly. Next, we can see the terminal crimped to the conductor. Here you can see the 2 crimped sections better. It is important to position the plastic all in the upper crimp section to fasten it securely. But it has to be completely out of the lower crimp section or the electrical connection will be bad. After crimping, we break off the tab and are ready to push the conductor with terminal into the position in the connector. Here are the rear side of the connector, where we push in the terminals. Push it firmly as far as they go and they will stay there. Be sure to put them in the correct positions. You need a special tool, and there may still be difficult to remove them from the connector again. Here we see the connector from the front side with the terminal pins. To crimp the contact elements on the conductors, we need some tools. First, we need a side cutter to cut the cable to suitable length. Don't cut it too short. This is just an example. Then they have to dismantle a piece of the cable sheath. There are different tools for this, but I like this kind. Then we have to remove some plastic stuff from inside it and possibly trim the cable sheath a little. Like this. Now we have the conductors. Now we have to remove the insulation on the tip of the inner conductors. There are different tools for this, but I like this type. It has 4 knife edges that cut the plastic from 4 sides. You select the diameter of the cutting on this wheel and set the length of the cutting with this stop, like this. When removing the cable sheath, you have to be careful not to cut into the conductors. And when removing the insulation, you have to be careful not to cut in the copper conductor itself. Now it's time to crimp. Take a connector element and you have to trim the conductor a little to fit. A little bit more. Like this. But for crimping, we need a crimping tool. To crimp the terminal to the cable, we need a tool. Best is a tool from the contact manufacturer, like this. They make a good crimping of both the conductor and the insulation, and they are easy to use. They have a tool to hold the contact element, the terminal, in position while crimping. You put the cable in position and crimp, and you get a nice crimping like this. Fast and easy. Some tools are like this for one terminal type only. Other tools are like this, where you can change this part for different terminal elements. There are a huge amount of different terminals that require different tools. The problem with these tools is that they are quite expensive. Between 500 and 2,500 euros, maybe too much for crimping a single connector. There are cheaper solutions. This is a tool from China and it works okay. The problem is you don't know if it works with this terminal or with that terminal. You have to try, and if you are lucky it works. If not, you have to try with another tool. This tool crimps both the copper conductor and the plastic on the cable in one go, but has no holder. So that makes it difficult to hold everything in the right position in the crimp moment. There are also this type of tools that crimps only one crimp at a time. Only the metal or only the plastic. So you must crimp each terminal 2 times. Also here you have to try with different tools before you find something that fits your terminal well. Of course you can make a not so good crimping and that might work too, but it's not reliable. People do all kinds of things and get away with it. Once you have crimped all the terminals to the cables, to the conductors, you push them into the connector in the right position, like has been done here. Then you have to secure the cable in some way to fix its position in the contact housing. To make this strong and good, place a piece of silicone hose, over it like this. This will protect the cable and help holding it in place when you tighten the screws in the connector. Even better is to use a second larger piece of silicone on top of the first, like this. And tighten the screws, like it's done here. In some radius you have no power in this connector, so you have to add an extra cable from the connector to an external power source. That might be available on another connector or in the plane's power distribution system. With 2 pieces of silicone, this cable can pass between the hoses, like it's done here. It will be kept safely in place. If other cables are already connected to the connector, you might need to find a different solution from the silicone hoses, but the idea will be the same. We may like to solder the connector instead of crimping. Here we can choose between soldering the extension cable or the cable from Aviation Companion with the 3.5mm plug removed. The cable ends will be identical. The cable is soldered to a connector that plugs in the radio. That connector may already have conductors soldered to it for headset, PTT and others. Before we start, put a piece of silicone hose over the cable, like this, if you want it. Also be prepared with a piece of shrink tube. Put it over the conductor before you solder it. After, we will be pushing it over the connector pins to protect the cable at the soldering. It is shrunk with heat from a heat gun. Do not use too much heat. And don't forget the shrink tube. You can't put it after soldering. I recommend to use shrink tube with glue inside. It's thicker, stronger and will not move by itself. So now it's time to solder the conductors to the connector. There are different ways to do this. Easiest if you put the conductor in correct position with one hand, and solder with second hand, and use the third hand for the soldering iron. Well, this can be arranged in different ways, but one easy way is to add solder to the connector pin first. For this I use a relatively cold soldering iron with a thick tip. High temperature tends to burn things. With a thick tip I can use lower temperature because it's not cooled down so much by the object and the solder. Lower temperature also means that the flow chemicals in the solder is not burnt away immediately. First I clean the soldering iron. It's easier to solder with a clean tool. Then I add a small amount of solder to the tip to get better thermal contact. add heat and solder to the pin just rapidly. And remove it before it flows away. I put a little tin on the conductor to make it fresh and easy to solder. Like that. I can even leave a little solder on it. Now it's time to fuse it together. The heat shrink tube is already on the conductor. Position it and heat it. Like that. Nice. Now we have to protect the soldering because the cable will break just at the soldering because of the heat treatment of the copper. We need to protect it with a heat shrink tube. This is a version with glue inside to make it stronger and keep it in place. Usually I do this for all pins at the same time. If you look carefully, we can see there comes a little bit glue out of the end of the heat shrink tube. Like that. And then do the same for the rest of the conductors. Before soldering anything, check to which pins each conductor shall be soldered. You can find that in the manual. You can see what signal is on which cable. Here. And in radio manual you can see what pins to connect those signals to. For some common radios it's also in the manual for Aviation Companion. You can also solder without putting any solder on the connector in advance. You then have to fix the conductor in some way, like here. Then you can solder quick and easy. Like that. It's a fast method, but it's more difficult.
This is the end of my presentation. I hope you liked it. I'm always happy to receive questions or suggestions from you to my email. Thank you for listening.